Have you ever wondered what would an animal score on an ethnicity test designed for humans? Well, after this video, you won't have to wonder at least about one animal, and the animal that you won't have to wonder about is a Siberian tiger, because for this video, I have mapped the genome of a Siberian tiger to the genome of a human, which means I got for you the genome of a Siberian tiger in human format, which means I will be able to run this Siberian tiger's genome through various human calculators made for humans, and we will be able to see what this Siberian tiger scores with various calculators made for humans. So we'll be able to see how much Sub-Saharan African, East Asian, whatever other admixtures he is scoring. Actually, she, because it is a female. So let's get into this video. So first, let's talk about where these Siberian tigers are located. They are located in Siberia and, of course, East Asia. They are located in Korea, China. This individual tiger is actually from this location right here in Beijing, Pekin. This is how we pronounce it in Russian. And this individual is female. It is a female tiger. She is from the Institute of Animal Sciences and the Chinese Academy of Agricultural Sciences in China. And the sample name is SAMN02374891. It's kind of irrelevant, but if you want to replicate my, if you want to find this specific sample and you want to like fact check whether I got you the right file, this is the sample name, just in case you want to like fact check me and whatever. You can look this up on ENA, and you can find this file by yourself, and you can do all this research yourself. Essentially, you can do this research by yourself. I'm leaving this information out there for you to be able to do this research. Let's see what this tiger actually scores. So that now that we got the information cleared up, it's a female. It's a Siberian tiger. The scientific name for it, I guess, is Panther tigris altaica. Let's dissect it a little bit. Panthera, I think that means that it's the genus is like Panthera. That refers to like feline type of. What does that mean? Panthera. Let's look it up. Panthera genus. Is a genus within the family Felidae. It's one of the two extant genera within the subfamily Pantherinae and contains the largest living members of the cat family. It contains tigers, jaguars, lions, leopards, and snow leopards, and a number of extinct species. Okay, so it's a pretty big family, and tigers are a part of this family. Very, very interesting. Tigress, I think that's like the distinction where it's Panthera, then it's Tigress. This is kind of like haplogroups, right? So you go haplogroups R1A, then you go Z645. That's kind of like the subclade. Tigress is kind of like the subclade of Panthera. So she's a tiger, and Altaica is kind of like the subclade of the tiger. This is kind of the type of tiger that she is. She's Altaic tiger. So she's Siberian tiger. So it kind of makes sense if you look at the scientific name for the genus as a like a haplogroup type thing, where the first word is the sort of like the root, and as you go to the right, it goes subclade, and then the subclade of the subclade. That's the way I read this this string of words. Now let's see what she scores for the Euroginsky 13. So with Euroginsky 13 based on 713 SNPs, which is not that much, she's scoring 42.9% Sub-Saharan African, mostly Sub-Saharan African. But what's really interesting is she's scoring 30% East Asian and 7% Northeast African and 7% West Asian. She's not scoring anything from Europe. She's only scoring 2% Baltic and 2% Siberian. Yeah, she's actually not scoring anything from Europe at all. No European whatsoever. She's only really scoring Sub-Saharan African and East Asian, and like some East Asian components like Oceanian as well, 3% Oceanian. So she's mostly really scoring Sub-Saharan African and East Asian. Kind of surprising. I was expecting her to score mostly Sub-Saharan African because from what I've seen so far, all of the non-human genomes I've seen score Sub-Saharan African. Like various gorillas, monkeys, they score Sub-Saharan African. If you look at wolf, even wolf scores overwhelmingly Sub-Saharan African. But for her, it's kind of the surprise is that she's scoring so much East Asian. That's the surprise for me, is that she's scoring 30% East Asian, and with the Oracle, she's actually scoring 58% Biaka Pygmy plus 41% Lahu. Lahu I think is Vietnam. There's also 55% Bantu plus 44% Malay. Malay I think is that's Southeast Asia as well. 42% Cambodian. Uh, Bantu plus Cambodian, Bantu plus Malay, Bantu plus Miazo, Bantu plus Cambodian once again. So a mixture of like African plus Southeast Asian is what she's scoring for the most part. Okay, so let's see what she scores with Yurojinsky 36. I'm not even gonna do calculated populations because you don't need calculated populations for K36. You don't really need that for that. And let's see what she scores with my own tool. Yeah, so for Yurojinsky 36, let's minimize that. Let's minimize that a little bit. Okay, so she's scoring 50.44% Pygmy. So the biggest component she scores is Pygmy. That's on the basis of 659 S&Ps. So she's scoring 50 over half percent Pygmy, basically over half Pygmy. 18.17% Armenian, 11.7% South Chinese. So there is that South Chinese admixture. Once again, there is that South Chinese or East Asian, like Southeast Asian admixture. 10.6% East Central Asian. There is once again that Central Asian or like East Eurasian admixture. 3.61% Indo-Chinese. There's once again that like Chinese or East Asian admixture. 2.6% East Asian admixture. 2.5% Omotic, and 0.2% Amerindian. So once again, this tiger is not really scoring any European components at all. So when it comes to human groups that this tiger is getting modeled as, it looks like this tiger is essentially getting modeled as a mixture of like African pygmy plus various East Asian groups. Definitely very interesting. So like pygmy or sub-Saharan African plus various East Asian groups seems to be the closest mixture, the closest human model for this Siberian tiger. Definitely very cool. When it comes to my trait predictor, unfortunately, this file is just so small that there is not a single SNP that can be used for ethnic calculator results, so I'm not even going to show you that. For polygenic risk scores, there's definitely something to show you, so let's look at that. It looks like this tiger has much higher than average odds for rheumatoid arthritis. This tiger has essentially higher than average odds for asthma. This tiger has pretty much average odds for bipolar type 1, very high score for Alzheimer's, above average odds for type 1 diabetes, much higher than average odds for multiple sclerosis. And that's pretty much all there is. That's all I can tell you here about this individual. So it looks like there's a lot of risk variance for various conditions that predispose this individual to various conditions in humans. But let's discuss stuff that this individual actually has in the genome that I can talk about, because there is not much. There really isn't much when it comes to this genome. When you map a genome of a tiger to the genome of a human, you lose a lot of the data, right? So you lose a lot of the data, unfortunately. So you end up with a very small, very low quality file in the end. This file is only 700, I think, kilobytes in size, so it's not very high quality whatsoever. And because of that, there is, as you can see, it's a very empty result. There is nothing for mental health results whatsoever. There is literally nothing I can talk about in this result. Let's talk about stuff I can talk about. So this individual is not a short sleeper. Doesn't have any pathogenic variants in PRNP. Very good to see. No dwarfism. Really good to see. Healthy genotype in this variation of G6PD. I don't even remember what that does. Healthy genotype in this variation of CLC2A1. I don't even remember what that does either. Okay. Predisposition to slightly lower odds of autism. Really good to see. No genotypes for OXTR. No genotypes for lactose persistence. For Alzheimer's, which is very, very interesting, this individual actually has two risk variants for Alzheimer's in this variation of APOE, which is very, very surprising. So this is one of the really important variations for humans, even for risk of Alzheimer's. That's kind of crazy, right? So APOE is a gene that's implicated in Alzheimer's risk in humans, and it is by far the most important gene for Alzheimer's risk in humans. And this um, leopard, this Siberian tiger, has two risk alleles for Alzheimer's in APOE, in this variation of APOE, which is kind of crazy. I don't think Siberian tigers have Alzheimer's. I don't think they do, but um, she does have two risk alleles here for Alzheimer's. Kind of crazy. Okay, lower odds for celiac disease in this variation, but it's in telomere panel. Very, very interesting. Um, Not an agent flusher. Lower odds of alcoholism. Normal risk of esophageal cancer. Okay. Risk of heart failure due to beta blocker medications is slightly below average. Looks like no holoprosencephaly, no Ehlers-Danlos syndrome, not a carrier for Sanfilippo syndrome risk, no risk evidence for GSS or BLM. Really good to see. Bloom syndrome is BLM, not the other BLM. No Riefenstein syndrome. Really good to see. For HLA, looks like this individual actually has highest odds for autoimmune disease. So there is looks like when it comes to HLA gene panel, there is definitely some risk variance for um, HLA. Let's see what's the problem with HLA here. Maybe there's something I missed. Yeah, there is something I missed. So HLA DRB1 homozygote 6 to 3 times higher risk for multiple sclerosis. That's the problem with the HLA here. So this person has some risk variance for multiple sclerosis in the HLA gene, and because of that, they score really badly on the HLA gene panel. Okay. No risk variance for any of the muscular dystrophy myopathies. Really good to see. For color blindness panel, nothing was found. For FTO gene panel, nothing was found. Biotrace panel, blood group panel, nothing was found. Well, that's pretty much all I can show you for this sample. Let's see some other ethnic calculator results. I'm sure that you want to see something else. How about Harappa World? Let's run Harappa World, and I'm going to show you with the Oracle as well. I'm going to stop sharing a little bit. Wow. There you go. Harappa World is done, and she scores 27.19% Sun, 19.4% Northeast Asian. Here, she's actually scoring some European. She's scoring 12.47% Northeast European, 11.26% West African, 9.98% Pygmy, 9.4% Southeast Asian, 6.3% Beringian, and 3.9% Baloch. And she's getting modeled as a mixture of Uyghur plus Kung, or Burmese plus Kung, or Kung plus Uyghur, or Kung plus Burmese. Kung, I think, is South African hunter-gatherer. So she's getting modeled as a mixture of South African hunter-gatherer plus Uyghur, or South African hunter-gatherer plus Burmese. So a mixture of basically Central Asian plus South African hunter-gatherer is what she's getting modeled as. So just kind of like a mixture of African and Central Asian, or African or East Asian, African and East Asian, or African and Central Asian seems to be what this individual is getting modeled as, with various ethnic calculators. Here with Harappa World, there is definitely a little bit of European ancestry that is found. Let's see you see the prediction with Harappa World. Let me zoom out a little bit. SNPs used 743 SNPs. That's definitely quite good. Good coverage for sure. Good coverage for sure, but I'm not sure how much I trust her scoring 12.47% Northeast European. Okay. 12.47% Northeast European, I guess. And because of that, because of her scoring 12.47% Northeast European, because of that, she's scoring Uyghur and Hazara and Uzbek and Kazakh instead of like Mongolian or Korean or something like that. It's because of that she's scoring all of these Central Asian groups instead of East Asian groups for the East Eurasian component. Very, very, very interesting. Well, thanks for watching until the very end. Leave a like and subscribe. The download for the raw data file will be in the description of the video. Thanks for watching my video until the very end. Leave a like and subscribe. Goodbye.